All right, welcome to Mr. Fields' kitchen here. Got the kitchen table and city scene there. Anyway, it don't matter. So we are going to talk about parabolas because it's March, first week of March here, and it's time to talk about parabolas. We will be using factoring, but whereas we were talking about the functions of quadratics, in standard form and factored form, we'll get back to that. But we're going to now start to look at the behavior graphically. All right. Let's get started then. So we're going to take some notes here. So if you would go ahead and draw a parabola in your notes, and then that. Now we could draw a parabola that is going downward as well, but we'll start with this one going upward. So we have these 2 points right here are called the zeros. We know them formally as the x-intercepts, and they are, but now they get some extra special names: zeros, roots, solutions. They end up playing some different roles. Okay, so then we also have the y-intercept, right? It's another key component. So this title is Quadratic Key Components. So the zeros are the x-intercepts, but I usually call them the zeros. We have the y-intercept. We have this bottom called the vertex. And in this case, it's a minimum, but we could also draw a vertex like this. This would be a vertex of a different kind, maximum. Okay, so they all have a vertex. And they have an axis of symmetry that goes right through the vertex. The vertex is the point that makes the parabola symmetrical one side to the other. All right, so every x coordinate has a y coordinate that another x coordinate has, same height. That didn't happen with linear functions. So let's go ahead and we're going to graph a parabola whose vertex is 3, 5. So we're going to put a point at 3, 5, and has a y-intercept of 1. There we go. All right, that was easy. Graph a parabola whose x-intercepts are -3 and 5. -3, 5, and whose minimum is -4. Okay, so we want to, let's make this our x-intercept, and minimum. Okay, so then we got to make this our minimum, and then we want to have 5 and -3. So, if I just move it right here, then I have 5, -3, and it works out. So have some fun with that one. Play around with the parabolas. Okay, so now we're gonna take these key components and we're gonna use them to interpret situations. So let me just add some things to this. So the y-intercept. I am trying to change the color. Oh, I see. There we go. The y-intercept is still the initial amount. But the vertex, can be the maximum amount of something or the minimum amount of something. And the zeros are, just like before with the linear function, the ending, or when something hits the ground. It could be, we'll see, when the profit changes. So we're just going to try to make some sense of these situations using the key components. So let's read this. Rico opens an ice cream shop. The function f models the shop's net worth in thousands of dollars as a function of time in months after Rico opens it. Plot the point on the graph that corresponds to the shop's net worth when Rico opens it. All right, so when he opens it, that's the initial value. That's the y-intercept. Okay. All right, Cassie hit a golf ball. The function f models the height of the ball above the ground as a function of time after she hit it. Yes, plot the point that corresponds to the ball's maximum height. And this reminds me that I actually taught my son about parabola. So, and please don't say parabola, because, well, I didn't want him to say parabola. And also, if you just, are playing with the hose in the summer, and the water goes in an arc when it goes into the air because of gravity, right? But it's actually a perfect parabola. Pretty cool, huh? So the maximum is up there. Okay. So now you can interpret a quadratic graph. So this one's a little bit more difficult. We can do it. As Sarah kicked the ball into the air, the function models the height of the ball as a function of time after she kicked it. So we can picture the soccer ball right up in the air and then boom, hits the ground right there, right? Which one of these statements are true? Sarah kicked the ball from a height of 1 meter. Well, where did she initially kick the ball from? Right here, right? So 2, 3, 4, 5. That looks like it's true. All right, so looks like she did kick it from 1 meter. Sarah kicked the ball from a height of 14 meters. No, that was her maximum height after she kicked the ball. At its highest point, the ball was 1.75 meters above the ground. No, it was like 14 meters. At its highest point, okay, it was 14 meters. There we go. We got it. All right, so you could do that. You can see if you can interpret those things and then just post in the organizer if you get a tough one or anyone you want, red, yellow, green. Okay, then we have the zero product property. What is that? Okay, that simply says that if A times B equals 0, A must equal 0 or B must equal 0. One of those guys is 0 because the product is 0. So we can use that because see, look, the factors multiply to 0. So what is the value of x that makes this equation multiply to 0? Well, it's got to be the x value that either makes this one 0 or the x value that makes this one 0, because we know one of those factors is 0 because it multiplies to 0. So which one is it? It could be 2 different x values. That's right. Now there are 2 solutions to one equation. That didn't happen with linear functions. Okay, so what is the answer to this one? -1, so that's one x value that will make this thing equal 0 because it would make this factor equal 0. If we substitute -1 in, it would look like this. Now, that wouldn't make the second one 0, but it would make the first one 0, which would make the whole thing 0 by the zero product property. Okay, now let's solve this one. And so we can see -4/3 is another value. Fraction, but that's okay. So the lesser is -4/3. And the greater is -1. Okay, so basically just set both of these factors equal to 0 and solve, and you got it. Now, let's take this quiz. Okay. I don't like these questions, but it's okay. They're good questions. They're just kind of a pain, right? So let's remember what we're doing. We're trying to compare linear and exponential functions. Okay, so switch gears. This is an exponential review assignment for the purpose of spacing and interleaving so that you don't forget all that important stuff. So this is exponential and this is linear. So let's go ahead and definitely you can use a calculator for this one because it's okay. So the 12 wild turkeys is increasing by 1.4. So we're going to keep multiplying 12 by 1.4. 16.8 times 1.4 is 23.52 times 1.4 is 32.982. 32.928 times 1.4, 46. I think that's going to be the one that does it. But let's go more. 64.5. So this is the first year. So at the first year, so that's first year, second year, third year, fourth year, fifth year, sixth year. Now this is the 18 is just increasing by 10. So 28, 38, 48, 58, 68. Oh my goodness. We gotta go another year here. All right. 490. Aha. 90.35. 78. So 7th year is correct. Good. Good thing. Got it. Okay, so remember the exponential function is like this is like P, and the growth would be 1 plus R to the T, and this whole inside is called the growth factor. And we know that the R is called the growth rate. T is the time, usually in years, and P is the initial amount, right? Okay, so reduce, oh no, by 3/5 each year. This would be 9,000 illiterate people in the country. Okay. But they're reducing by this much each year. So that's not a growth factor, that's a decay. That's a decay factor. The decay rate. So they want to reduce it by that much each year, which means they want to keep 2/5, right? So if we do 1 minus 3/5, and that's 2/5. Right? I'm wrong, but I'm going with it. 9,000 to 2/5 the T. All right. I got it. Okay, so if it's the decay factor, then we want to subtract that from 1. And if it's the growth rate, we want to add that to 1. If it's the decay rate, we want to subtract that from 1. If it's the growth rate, we want to add that to 1. If they gave us the factor, we could just substitute that in. All right. 6 is the y-intercept, and our growth rate is 1/3. So we're going to make a table. X, Y, we know we got 0, 6, and then 1. So what times 6, or 6 times 1/3 is what? 6 times 1/3 would be 6 over 3, which is 2. Oh, that's 1, 2. 1, 2. All right. So just remember that this little guy is what is being multiplied. We're multiplying each y coordinate by to get the subsequent y coordinate. And sometimes you got to do some cross multiplication. What is the shape of the graph of this function? Well, this has a growth factor of 3, so that would be growth. If the factor is between 0 and 1, it would be decay. That is not the case. Graph the function. All right, well, the y-intercept is 2 and the growth rate is 3. Let me just make a table again. So I know that we have 0, 2, and that our growth rate is 3. So we're going to multiply by 3. So that means 2 times 6 is 6. So we can point at 1, 6. Got it. Hope you really enjoy this week's assignments. A lot of good stuff there. I'll see you in class.